2 trillion galaxies, and you sitting on one small planet in one ordinary corner of one of them. Sit with that for a moment. 2 trillion, not 2 trillion stars, 2 trillion galaxies, each one packed with 100 billion stars, give or take an order of magnitude. And here you are, told by almost everyone you've ever met that all of it, every last spiral and every last cloud of gas, was made for one place, one rocky world, one kind of creature, you. Now, I know how that sounds. I'm not here to tell you what to believe about God or the soul or the meaning of your Sunday morning. That's yours. I wouldn't dream of touching it. But I do want to walk you through a question that has kept me up at night, and I think it might do the same to you. Because when you actually do the arithmetic, when you count what's out there, and then look at how much of it seems to be doing nothing at all, something very strange starts to stare back. Why would you build a house with 2 trillion rooms and furnish only one? That's the question. And the honest answer is, we don't know yet. But we know exactly where the edge of our not knowing sits. And that edge is one of the most thrilling places a human mind can stand. So let's stand there together. Let's not rush to comfort. Let's just look. Here's what I want you to notice before we go anywhere. The number 2 trillion is not a guess someone shouted at a party. It's a measurement. And the fact that we can even measure it from the surface of a single planet without ever leaving is the first small miracle in a story full of them. And notice something else before we've even taken a step. The people who tell you the universe was made for you and the people who tell you it's a cold and pointless void are making the very same move. Both of them are certain. Both of them have decided the case is closed. What I want to offer you is stranger and, I think, better. A place where the case is open, wide open, and the not knowing is the good part. So let me show you how anyone knows anything at all about the sky, because everything that follows depends on it. If the foundation is shaky, the whole cathedral falls. Start with the simplest thing you own, your eyes. On a dark night, far from any town, you can see maybe 3,000 stars. That's it, 3,000 pinpricks. For most of human history, that was the entire universe. Every star anyone had ever seen, every myth, every navigation chart, all of it drawn from 3,000 dots. And here's the thing worth sitting with. Those people were not stupid. They were you with the same brain working with less light. The gap between what they believed and what was actually out there was not a gap in intelligence, it was a gap in instruments. That gap is the whole story. Hold on to it. Think about how much of what those people believed came from filling that gap with a story. They looked at 3,000 dots and drew hunters and bears and rivers across the black. They weren't wrong to draw. They were wrong to think the drawing was the thing. And this is the trap that catches every generation, including yours and mine. We look at what we can see, and we quietly assume that what we can see is all there is. That assumption feels like humility. It feels like sticking to the facts. It is actually the boldest, most reckless claim a person can make. To say the universe ends where my eyesight ends is to put myself, once again, at the center of everything. Now, how do you measure the distance to a star you can never visit? You'd think it would be impossible. It's not. It's geometry, the same geometry you half remember from a classroom, and it works like this. Hold your thumb out at arm's length. Close one eye, then the other. Your thumb jumps against the background. That jump is called parallax, and the amount it jumps tells you how far away your thumb is. Move your thumb closer, it jumps more. Further, it jumps less. The Earth does exactly this. In summer, we're on one side of the sundae. In winter, we're on the other. That's a baseline of about 300 million kilometers. So a nearby star, watched in summer and again in winter, jumps a tiny amount against the more distant stars. Measure the jump, and simple geometry hands you the distance. No spaceship required. Just patience and a good eye and the willingness to wait 6 months between measurements. And I want you to feel how tiny that jump really is, because it tells you how big everything is. Even for the nearest stars, the shift is smaller than the width of a coin seen from 10 kilometers away. That's why it took so long to catch. Not because the ancients were dim, but because the effect is so faint, it hides beneath the wobble of the air itself. It took centuries of sharper instruments before anyone could measure a single star's distance this way. And when they finally did, the number that came back was so large it frightened people. Because the moment you have one honest distance, the cozy little universe folds up and blows away. But here's the beautiful part about this method. It builds on itself. Once you know the true distance to nearby stars by parallax, you learn how bright they truly are, not just how bright they look. And once you know how bright a certain kind of star truly is, you can spot that same kind of star much further away, see how faint it appears, and work backward to its distance. Then those stars teach you about whole galaxies. It's a ladder. Each rung is built on the rung below it, and the very first rung is nothing more than a thumb, an eye, and the width of Earth's orbit. Kick out that bottom rung, and the whole ladder falls. So every colossal number we're going to reach rests on that humble little jump of a thumb. Never forget how modest the foundation is. That's how we got the first honest ruler for the cosmos. And it gave us a word you're going to need: the light year. A light year is not a measure of time, even though it sounds like one. It's a measure of distance. It's how far light travels in 1 year, and light is the fastest thing there is. Nothing outruns it, nothing catches it. Light covers about 300,000 kilometers every second, and it keeps that up for a full year. That distance, that enormous distance, is 1 light year. Let me try to make that speed real, because numbers slide off the mind unless you pin them down. Light could circle the entire Earth 7.5 times in a single second. In the time it takes you to say the word Mississippi, light has crossed the gap between here and the moon. And yet, even at that impossible pace, it takes light over 8 minutes to reach us from our own Sunday. So the sunlight warming your hands right now left the sun 8 minutes ago. If the sun blinked out this instant, you would not know for another 8 minutes. You are always, in a sense, looking at a sun that already happened. The nearest star to our sun sits a little over 4 light years away. Sit with what that actually means. The light hitting your eye from that star tonight left it more than 4 years ago. You are not seeing the star. You are seeing its past. You are looking at a ghost of where it was. And this is the key that unlocks everything. When you look far, you look back in time. There is no other way to do it. Distance and time are the same currency out here. The further out you point the telescope, the deeper into the past you are staring. Look far enough, and you can see the universe when it was young. That's not poetry. That's just what light is and how slow it turns out to be across distances this large. Now push that idea until it aches. The nearest big galaxy to ours sits about 2.5 million light years away. So the light arriving from it now left before there were people on this planet. When you look at that faint smudge in a dark sky, you are seeing a galaxy as it was before your species existed. And that's the near neighbor. That's the one next door. The 2 trillion we're counting stretch back billions of years, which means the map of the sky is not a photograph of how things are. It's a scrapbook, every page from a different age, all pasted together and glowing at once. You never see the universe as it is. You only ever see it as it was. There is a limit to this, and it matters. So let me hand it to you now. Look far enough back and you hit a wall. Not the edge of space, but the edge of what can ever be seen. In its first few 100,000 years, the universe was so hot and thick that light couldn't travel through it at all. It bounced, trapped, like light inside fog. Then it cleared all at once, and that first freed light is still arriving today, stretched and cooled into a faint hum of radiation we call the cosmic microwave background. It is the oldest picture there is, and it is a curtain we cannot see behind it, not with any telescope we could ever build, because there was no free light before it to see. That's not a gap in our instruments. That's a genuine boundary on what is knowable. And knowing exactly where that boundary sits is itself a kind of triumph. And I want you to appreciate what that curtain is made of. It isn't a wall someone built, it's simply the moment the fog lifted. Turn any radio to an empty channel, and a little of that static hiss you hear is that ancient light, 13 billion years old, arriving in your living room. The oldest thing in existence, pouring through the roof. And for decades, people heard it and thought their equipment was dirty. That's the pattern again. The universe was whispering its beginning to us, and we mistook it for noise until someone thought to ask what the noise was. So we built bigger eyes. Telescopes gather more light than your pupil ever could, and they hold that light still, and they let us count things too faint to see. A big telescope is really just a bigger bucket for catching light and a longer stare, where your eye takes in a scene and refreshes it many times a second. A telescope can hold its gaze open for hours, piling up faint light until a smudge too dim for any human eye slowly rises out of the dark. And when you point a truly enormous telescope at a patch of sky that looks completely empty, a patch the size of a grain of sand held at arm's length, you do not find emptiness, you find galaxies, thousands of them, in a speck of nothing. Do that math across the whole sky, and you get your 2 trillion. It's not a mystic's number. It's a head count done carefully with error bars by people who would happily tell you if they were wrong, because that's the rule here, the only rule that matters. A claim is only worth anything if there's an observation that could kill it. If nothing could ever prove it false, it isn't science, it's just a feeling wearing a lab coat. The word for that is falsifiable, and it's the sharpest tool we've got. And I want you to notice how that rule protects you. It means nobody here gets to win an argument by being loud, or by being important, or by having letters after their name. The sky doesn't care who's talking. A claim stands or falls on whether reality could contradict it. That's why I keep saying we don't know yet instead of pretending. Because the moment we pretend, we've left the only ground that's ever held any weight. This whole way of thinking, this refusal to believe a thing until it survives a test that could have killed it, has a plain name: scientific literacy. It isn't knowing a pile of facts. It's knowing how to tell a real answer from a comforting one. So here's where we stand before we've even started. 2 trillion galaxies, counted from a single rock, using geometry and patience and light that's older than the dinosaurs. And the deeper we look, the emptier of company it all seems to be. That's the puzzle. Now let's actually chew on it. Let me give you the first thought experiment, and I want you to do it with me, not just watch me do it. Imagine the universe is completely ordinary, not special, not centered on anything, just average. Everywhere you look, this is an actual principle, and it has a name: the Copernican principle. It says you are not in a special place. Copernicus figured out the Earth wasn't the center of the solar system, and every discovery since has driven the same lesson deeper. We're not the center of the solar system. The solar system isn't the center of the galaxy. The galaxy isn't the center of anything. There is no center. You are, as far as we can tell, standing somewhere thoroughly unremarkable. And every single time humanity has bet against this principle, it has lost. We bet the Earth was the center. Wrong. We bet the sun was the center. Wrong. We bet our galaxy was the whole universe. Wrong again. And by a factor of 2 trillion, there's a mediocrity assumption buried in here, and it has one of the best track records in the history of human thought. It says when you don't know where you sit in a distribution, assume you're somewhere ordinary. Not the best seat, not the worst, just a middling one. And it keeps being right over and over, because ordinary seats are the ones there are the most of. Let me make that assumption feel solid, because it's easy to hear it as a shrug. It isn't. It's the safest bet there is, and here's why. Picture a vast hall filled with 1 million chairs, and you're dropped into one blindfolded. Should you guess you've landed in the single best chair in the room? The odds against that are 1,000,000 to 1. Should you guess the worst? Same odds. The smart money every time says you're somewhere in the crowded middle, because that's where nearly all the chairs are. Now apply that to your address in the cosmos. To believe Earth is the one special world is to bet you landed in the best chair blindfolded, out of a hall with more chairs than there are grains of sand on every beach on the planet. The mediocrity assumption isn't pessimism. It's just refusing to make the wildest bet available. Now, run that principle forward, because it has teeth. If your planet is ordinary, and your star is ordinary, and your galaxy is ordinary, then whatever happened here should happen elsewhere. Life arose on an ordinary rock around an ordinary star. So life should arise on other ordinary rocks around other ordinary stars. That's not wishful thinking. That's just refusing to believe you're the exception, which is usually the safest bet in a universe this size. Let's put numbers on it, and let's build them from scratch so you trust them. There's a beautiful piece of reasoning called the Drake equation. Don't let the word equation scare you. It's just a way of breaking one impossible question into smaller answerable ones. The impossible question is, how many civilizations out there could we talk to? And instead of guessing, you chain together the pieces. How many stars are there? How many have planets? How many of those planets sit in the Goldilocks zone, the region around a star that's not too hot and not too cold, where water could stay liquid, not boiling away, and not frozen solid? On how many of those does life actually start? On how many does life get complicated? How many build technology? And how long do they last before they vanish? Multiply all those together and you get a number. Now, here's the honest part. We only know the first couple of terms well. The rest are guesses. But watch what happens even with cautious guesses. There are 100 billion stars in our galaxy alone. Suppose only 1 in 5 has planets. That's 20 billion planetary systems. Suppose only 1 in 5 of those has a world in the Goldilocks zone. 4 billion in one galaxy. Now, suppose life is rare, brutally rare, a 1 in a million fluke. You'd still get 4,000 living worlds in our galaxy alone. And there are 2 trillion galaxies. I want to slow down on that chain because the beauty of it is that you can turn every dial yourself. You don't have to trust me. You don't have to trust anybody. Every term in that equation is something you can argue about at your own kitchen table. Hate my number for how many stars have planets. Change it. Think life almost never gets past pond scum? Turn that dial down as far as your conscience allows. The equation doesn't demand you believe anything. It just makes your assumptions honest, out loud, where you can see them. That's the whole point of it. It was never really built to give a final answer. It was built to organize our ignorance, to show us exactly which unknowns matter most, so that when a telescope finally measures one of them, we know precisely which dial just got locked into place. And I want to be fair to the pessimist here, because fairness is the whole game. Suppose you don't like my 1 in 5 for planets. Fine. We now know from watching thousands of real exoplanets that pass in front of their stars and dim them ever so slightly, that planets are not rare at all. Most stars have them. So if anything, I lowballed it. Suppose you hate my 1 in a million for life. Push it to 1 in a billion, 1 in a trillion. Make life a miracle so improbable it should almost never happen. Run the numbers again across 2 trillion galaxies, each with its billions of decent worlds, and you still can't get the expected count of living planets down to 1 without making life very nearly impossible on purpose. That's the thing that should stop your breath. The scale is so vast that to make yourself alone, you have to rig the equation until it screams. Let me put a real edge on that so you feel the size of it. Add up the decent worlds across 2 trillion galaxies, and you're looking at something like 1 billion trillion planets in the Goldilocks zone. Write that out, and it's a 1 with 21 zeros after it. Now, to make Earth the only living world among all of those, life would have to be a fluke, rarer than 1 in 1 billion trillion. Think about what you're claiming if you believe that. You're claiming the exact chemistry that happened in some warm puddle here is so staggeringly unlikely that it beat odds of 1 billion trillion to 1, and then having beaten them, it happened to land on your street. Could be true. The universe owes us nothing, but feel how heavy that claim is. You'd be betting on the single most improbable event in all of existence and betting it happened right here at home. Even when you stack the odds savagely against life, the sheer size of the universe drowns your caution. That's the point. The numbers are so vast that being pessimistic barely dents them. So the Copernican principle, followed honestly, screams that the universe should be crawling with life. The place should be a carnival. And here's the turn. It looks empty. We've been listening. We point instruments at the sky and search for a techno-signature, a sign of technology, a radio whisper, a laser pulse, anything that nature couldn't make on its own. Decades of listening. And the sky is silent. This is the Fermi paradox, and it's the sharpest knife in this whole conversation. The reasoning says they should be everywhere. The evidence says the phone isn't ringing. Both of those are true at once. And the gap between them is one of the deepest mysteries a human being has ever been able to hold. Follow the logic all the way, and it gets worse. Or better, depending on your appetite for a good puzzle. Our galaxy is 100,000 light years across. Sounds impossibly big. But the galaxy is over 10 billion years old. Suppose a civilization arose somewhere, anywhere, and started spreading, even crawling from star to star at a fraction of light speed, even taking 1 million years between hops. You could visit every single star in the galaxy in a few tens of millions of years. That's a blink. The galaxy has had time for that to happen 1,000 times over. Let me make that arithmetic solid, because it's easy to wave past. Say a civilization sends out slow ships, and each new world it reaches takes 1,000 years to settle, and then 1,000 more before it launches ships of its own. That's painfully slow. And still, that wave of settlement spreads outward, world by world, and the whole galaxy fills in something like 5 to 50 million years. Set that against a galaxy that has been around for more than 10 billion years. The time available is 1,000 times longer than the time it would take. So even one civilization ever, anywhere, with even a little patience, should have washed across the whole galaxy long before we showed up. The empty sky isn't just quiet. It's quiet in a way the clock says it has no right to be. And here's what really tightens the knot. You don't even need the ships to carry living things. You could send machines, a single craft that lands on a world, digs up raw material, and builds 2 copies of itself, which then fly off and do the same. 2 becomes 4, 4 becomes 8. That doubling, even at a crawl, sweeps a galaxy clean in a cosmic instant. It only has to happen once, anywhere, in 10 billion years for the evidence to be sitting on our doorstep right now. And it isn't. So either nobody ever did it in a galaxy that begs for it, or they did and we can't see it, or there's simply nobody there to do it at all. Every one of those answers is astonishing. There's no boring way out of this room. So where is everybody? The reasoning says they've had time to be here. The mailbox says nobody came. That's the first revelation, and I don't have a bow to tie on it. I have a hole in the floor. The mediocrity of our position argues for a crowded cosmos. The evidence of our senses argues for an empty one. Sit with that. Don't fill it in too fast. The discomfort is the whole point. Now let me take you somewhere completely different and watch, because the shape of the problem is going to repeat. For all of human history, everything we ever studied in the sky belonged to us. Every planet, every comet, every asteroid, born in our own solar system, bound to our own sun, circling in the great slow clockwork we call orbital mechanics, the physics of how things fall around one another under gravity. We had never once touched something from outside. Not a pebble, not a grain. And there's a reason we felt sealed off, and it's worth naming. To leave a star system, you have to beat its gravity. That's escape velocity, the speed you need to break free and never fall back. From Earth's surface, it's about 11 kilometers a second. From the sun's grip out here, where we live, it's higher still. Everything born in our system is, by definition, moving too slow to escape. It's trapped on a leash, looping around forever. So when something comes through moving faster than the sun could ever have flung it, you know instantly it wasn't born here. It's carrying the speed of another star's farewell. That single fact, a number about speed, is enough to unmask a stranger. Let me show you how clean that piece of reasoning really is, because it's a small marvel of armchair detective work. Every object bound to the sun moves on a closed loop, and there's a top speed the sun can give it at any distance. Past that speed limit, and gravity can no longer hold you. You're not on a loop anymore. You're on a one-way path, arriving from infinity and departing to infinity, just bending once around the sun as you pass. So a person watching from Earth doesn't need to know where an object was born. They only need to clock its speed and trace its path. Too fast and open, and the verdict writes itself. This thing was never ours. It fell in from the dark between the stars. No spaceship sent, no sample caught. Just careful measurement of speed and direction, and a conclusion that could not be dodged. Then, a few years ago, something fell through. An object came screaming into the solar system on a path that made no sense for a local. Everything born here follows a closed loop, a leash tied to the sun, coming back around. Eventually, this thing was on an open path. It came from the dark between the stars, whipped around the sun once, and left never to return. It was the first confirmed interstellar object we had ever seen. A visitor, something that had spent perhaps hundreds of millions of years crossing the void between stars, and happened to pass through our little neighborhood while we finally had eyes sharp enough to catch it. Let that land. A piece of another star system in our own backyard for the first time in human history. And we almost missed it. It was already leaving when we found it. We caught it on its way out the door, a fading dot, and had only days to study something that had traveled for ages to get here. That's how thin our attention still is. We didn't see it coming. We saw it going. Now here's where it gets strange, and here's where the reasoning turns. As this object rounded the sun and headed back out, it sped up. Not by much, but by more than gravity alone could explain. Gravity is a very well understood thing. We can predict where a falling object goes with astonishing precision. We landed craft on comets using this arithmetic. So when something moves faster than gravity says it should, that extra push is called non-gravitational acceleration, and it demands an explanation. For a comet, the explanation is easy and boring is usually right. A comet is a dirty snowball. When it nears the sun, ice turns to gas, jets out one side, and shoves the comet along like a tiny rocket. Perfectly natural. Happens all the time. And when you reach for the simplest explanation that fits, you're using Occam's razor, the old rule that says, don't invent a dragon when a lizard will do. But this visitor didn't look quite like a comet. The venting wasn't obvious. Normally, when ice boils off a comet, you see it a glowing tail, a fuzzy halo of gas and dust. Here, the usual signs were faint or missing, and yet the push was there. The shape was strange, long and thin, tumbling end over end. And so, for a little while, a serious and careful question got asked out loud. What if the push wasn't from venting ice? What if it was from something thin and flat, catching starlight the way a sail catches wind? What would have to be true for this rock to be something built? Now hold on. I am not telling you it was a spaceship. Almost certainly it wasn't. The likeliest answer is some exotic natural object we simply haven't cataloged before. An oddball chunk of ice or metal doing something unusual but perfectly natural. Perhaps it was venting a kind of ice that leaves no visible tail. Perhaps it was a fragment of something larger shaped by forces we've never watched up close. That's where Occam's razor points, and I'd bet my house there. But I want you to sit with why that question was worth asking at all. Because this is where people get the whole spirit of it backward. Asking, could it be built, is not the same as claiming it was. A good thinker doesn't refuse to ask a question just because the answer would be startling. A good thinker asks it precisely, names exactly what evidence would tip the scales one way or the other, and then goes looking. The scandal would have been to see something we couldn't explain and forbid the strange explanation without checking. That's not caution, that's cowardice dressed as rigor. Real rigor keeps the door open and demands proof before walking through it. But here's the turn, and it's the real one. The point was never the answer. The point was the question was allowed. For the first time, we had a real physical object from another star behaving in a way we couldn't fully explain. And the honest scientific response was not to laugh, it was to say, we don't know yet. And here is exactly what would settle it. Get a closer look, measure the surface, see what's pushing it. Name the observation that would prove you wrong, then go and try to make it. Then a second one came, and a third interstellar visitor after that tracked as it fell through, studied harder than the first, because now we knew to watch each one a message in a bottle from somewhere we can never go. And each one telling us the same quiet, staggering thing. The stuff of other star systems drifts through ours all the time. It always has. We were just blind to it. And once you find 3 in a handful of years, right after you finally build eyes good enough to spot them, the arithmetic is merciless. If we caught 3 the moment we could see it all, then the true number streaming through, most of them too faint or too fast to catch, must be enormous. There could be thousands crossing our solar system at any given time. The gap, again, was never in the cosmos. It was in our instruments and our attention. And the moment we built better eyes, the visitors were suddenly everywhere, streaming through as if they'd been waiting the whole time for us to look up. Let me do that arithmetic with you, because it's the kind of reasoning you can check yourself. Space is enormous, and a solar system is a tiny target. For a survey that watches only a slice of the sky, only part of the time, to catch 3 of these things in just a few years, the sky can't be nearly empty of them. If you find 3 fish the very first time you dip a small net into a huge dark lake, you don't conclude the lake holds 3 fish. You conclude the lake is teeming, and your net is just small. Run that logic honestly, and you're forced to picture a solar system with these interstellar wanderers passing through constantly, most of them slipping by unseen in the dark, too faint to catch, out beyond where our nets can reach. The neighborhood was never sealed. It was crowded. We were simply blind. So sit with the shape of this. We thought we were sealed off, alone in our own little bubble of sun and planets. We weren't. The walls were never there. Material from across the galaxy passes through this neighborhood, and the only thing that ever kept us companyless was our own inability to see it. What else is passing through right now? Unremarked, because we still aren't looking in the right way. That's the second hole in the floor. Same shape as the first. We assumed isolation. The evidence, once we could gather it, whispered connection. Let me take you to the third place. And this one is the deepest, because now we're not talking about space. We're talking about time. Point the most powerful telescope ever built at a dark patch of sky and hold it open. Let the ancient light pour in. Remember the rule, to look far is to look back. So when you gather light that has been traveling for over 13 billion years, you are seeing the universe as an infant. You are looking at the beginning, and there's a trick to catching light this old, and it's beautiful. As that light crosses billions of years of expanding space, it gets stretched, its waves grow longer, sliding from visible light toward the infrared. The warm invisible glow just past red, we call that stretching redshift. And the more a thing's light is stretched, the further away and further back it is. So to see the oldest galaxies, you don't build an eye for visible light at all. You build one for infrared, tuned to catch light that started out as a blue-white blaze and arrived 13 billion years later as a faint red whisper. Sometimes we even get help. A massive cluster of galaxies sitting between us, and the target bends the light around it with its gravity, acting as a lens, a phenomenon called gravitational lensing, magnifying something otherwise too faint to ever see. The universe hands us a magnifying glass made of galaxies. I want you to really feel how strange and clever that last trick is, because it comes straight from the deepest idea we have about gravity. Mass bends the path of light. Put enough mass between you and a distant object, and the light that would have sailed past on all sides gets bent inward toward you instead, gathered up, focused, brightened. So a cluster of galaxies becomes a lens nobody ground, nobody polished, hanging in space, doing our work for free. We point our telescope not quite at the thing we want, but at the giant lens in front of it, and let the cluster's gravity haul into view a galaxy so faint and so far that no bucket we could ever build would catch it on its own. Think about that. We're using the weight of the foreground universe as a telescope to see the background universe. Nobody planned that. The physics simply allows it, and we noticed, and we used it. And here is what the reasoning predicted we would find. The early universe should be simple, crude. The first galaxies should be small, faint, messy, half-formed, little clumps of gas just beginning to organize themselves. It takes time to build a grand spiral galaxy. It takes time to forge the heavy elements, the carbon and oxygen and iron in the furnaces of stars, and then scatter them and then gather them again into new stars and new worlds. That's the story we told ourselves. And it was a good story built on solid physics. The young universe should look young. We built the eyes. We looked, and the young universe did not look young. The earliest galaxies came back too big, too bright, too finished, too full of structure, too soon. Galaxies that should have needed billions of years to assemble were already there, grand and grown, when the universe was barely a toddler. It was as though you photographed a maternity ward and found the newborns already reading books. Now, what do you do with that? This is where the whole spirit of this thing shows itself, and I love it more than I can say. You do not panic. You do not throw out physics. You do not declare a miracle. You say our expectation was wrong, and the universe is under no obligation to match our expectations. The data is the boss, always. When a beautiful idea meets an ugly fact, the fact wins every time, and the beautiful idea has to be rebuilt. So maybe galaxies form faster than we thought. Maybe the first stars were bigger and burned hotter, monsters hundreds of times the mass of our sun, lighting up the dark in a rush. Maybe we're being fooled, and some of that brightness comes not from stars, but from matter spiraling into an enormous black hole at a galaxy's heart, blazing as it falls past the point of no return. The event horizon, the boundary beyond which not even light can climb back out. Maybe there's a piece of the puzzle we haven't found. Maybe it involves dark matter, that invisible stuff that outweighs everything. We can see by a factor of 5 to 1, tugging on galaxies with its gravity while giving off no light at all, the great silent scaffolding of the cosmos that we still barely understand. We don't know yet. And that phrase, "we don't know yet," is not a defeat. It's an invitation. It's the sound of the boundary of human knowledge moving live in your lifetime. And I want you to notice how each of those maybes is a real testable road, not a shrug. If the first stars were monsters, they'd leave a particular chemical fingerprint we can go looking for. If the brightness comes from feeding black holes, it flickers and glows in a way that gives itself away. If dark matter is arranging things faster than we thought, that changes exactly where and when the earliest galaxies should appear, and we can go count them and check. Every one of those guesses names its own executioner in advance. That's what makes them worth anything. A guess that can't be killed isn't a scientific answer. It's a security blanket. The maybes that survive will be the ones that stuck out their necks and live. Here's the turn, and it's the biggest one. Every time we've built a better instrument, the universe has come back richer, older, stranger, and more full than we expected. Never emptier, never simpler, never smaller. The pattern of every discovery ever made runs in one direction. Whatever we guessed, the reality turned out to be more. Think about what that does to the question we started with. We look out, and the sky seems silent, seems empty, seems built for us alone. But every single time we thought the cosmos was smaller or emptier or simpler than it turned out to be, we were wrong. The consistent lesson of 400 years of looking is that our sense of the universe's fullness is always an underestimate. So when you feel that the universe seems empty of company, ask yourself honestly, is it empty? Or are you the person with 3,000 stars certain that's all there is on the night before someone builds a bigger eye? That's the third hole in the floor. And now watch what happens when I lay all three side by side. 3 times now, we've walked the same road. Look at the shape of it. Every single time, we started from a belief about how small or empty or finished the universe was. And every single time, the moment we looked harder, The universe turned out to be bigger, fuller, more connected, more alive with possibility than we dared to assume. The Copernican principle told us life should be common, and our silence made us feel alone. But we've barely listened. We've searched a puddle's worth of the ocean. Think about what a real search would mean. There are billions of stars in our galaxy alone, and for each one, countless frequencies to listen on. And you have to be pointed at the right one, on the right frequency, at the right moment, to catch a signal that may only shine our way for an instant across light years of distance. We've been at it for a few decades, checking a tiny sliver of the sky on a handful of channels, listening for a species that only learned to make radios a blink ago. To conclude, the universe is empty from that is like dipping a cup into the sea, finding no whale, and declaring the ocean lifeless. The silence isn't evidence of absence. It's evidence of how little we've checked, and there's a cruelty to the timing that makes it worse, and you should feel it. We've been able to make radio signals for barely 100 years. Our whole broadcasting history is a candle flash against the 10 billion year age of the galaxy. So even if 1,000 civilizations rose and fell out there, each one shouting into the void for a few centuries, the odds that any of them were shouting at the exact sliver of time we happen to be listening, pointed at the exact patch of sky where they lived, are painfully thin. Two ships crossing a vast dark ocean, each with a lantern lit for 1 minute out of a century. That they never saw each other's light proves nothing about how many ships there are. It only proves the ocean is huge and the lanterns are brief. The interstellar visitors told us we were never sealed off. We felt alone in our own solar system, and then real objects from other stars came drifting through again and again, and we realized they'd always been coming. The walls we imagined were never there. The isolation was in our eyes, not in the cosmos. And here's the quiet marvel folded inside that. Those visitors are made of the same stuff we are, forged in the same kinds of stars, obeying the same physics. The galaxy is not a collection of sealed rooms. It's one connected place, and the doors have been open the whole time. And the ancient galaxies told us that even time itself is fuller than we thought. The universe got busy faster, built more, sooner than our best story predicted. Look toward the beginning, and you don't find emptiness. You find abundance arriving early, refusing to wait for our theories to catch up. Do you see it now? Do you see the single thing all three are pointing at? Every instinct we have toward emptiness has been wrong. Every one. The feeling that the universe is barren, that only our one galaxy is furnished, that we are the single lit window in 2 trillion dark houses, is not a finding. It's a failure of imagination dressed up as humility. And it fails for the same reason it always has. We mistake the edge of our instruments for the edge of reality. We mistake how far we can see for how far there is. So come back to the question we opened with. Why would God create 2 trillion galaxies and fill only one? And notice, gently, what's hidden inside it. The question assumes the other galaxies are empty. It smuggles that in as a fact. But that emptiness is precisely the thing we have never once measured, and precisely the thing that every measurement we have ever made warns us against believing. We have not confirmed a single empty galaxy, not one. We've confirmed exactly one full one, the one you're standing in, and we've barely begun to check next door. To say the rest are empty is not knowledge. It's the 3,000 stars again. It's the sealed solar system again. It's the young universe that turned out to be old. It's the same mistake, wearing the same disguise, walking in through the same door it always uses. Whatever you believe about who made all this, and I hold your belief in genuine respect, the arithmetic points somewhere humbling and thrilling at once. If a mind built 2 trillion galaxies, the evidence of our own history suggests it did not build them to sit empty, because everywhere we've ever managed to look closely, we've found more than we expected, not less. The universe has never once disappointed us by being smaller than we hoped. So let's bring it home. Let's walk back through the whole thing, because I don't want a single piece of this to slip away from you. We started with an impossible question and 2 trillion galaxies. And before we'd answer anything, we asked how anyone could possibly know such a number from a single planet. We found the answer in the humblest place, In your own two eyes, in the jump of a thumb held at arm's length, in the patient geometry of parallax that measures a star's distance without ever leaving home, we learn that light is fast but not infinite, that a light year is a distance and not a duration, and that to look far into space is always, unavoidably, to look back in time. Distance and time, the same currency. And we found the one wall we can't see past, the cosmic microwave background, the oldest light there is. And we learned that even knowing where the wall stands is a kind of knowledge. Then we did the reasoning honestly. The Copernican principle, the plain refusal to believe we're special, insisted that if life started on one ordinary world, it should start on countless others. We built that up piece by piece with the Drake equation, turning every dial ourselves, and we found that even when we made life absurdly rare, the sheer scale of 2 trillion galaxies buried our pessimism. We tried to rig it toward loneliness, and we couldn't. Not without making life a fluke, rarer than 1 in a billion trillion, and betting that impossible fluke landed on our own street. The reasoning demanded a crowded cosmos, and yet the Fermi paradox stared back, the phone silent, the mailbox empty, and the clock insisting that anyone, ever, even a single self-copying machine, should have had time to reach us. We sat in that gap and refused to fill it too fast. Then the visitors came, interstellar objects, real physical pieces of other star systems, falling through our own for the first time in human history, one carrying more speed than the sun could ever have given it, one showing a non-gravitational acceleration we couldn't fully explain. And whether it was venting ice or something stranger, the lesson held. We were never sealed off. The walls were never there. 3, caught in a handful of years, means thousands passing unseen. The way 3 fish in the first dip of a net means a lake that teems. The galaxy has been drifting through our neighborhood the whole time, and we simply lacked the eyes to notice. Then we look back toward the beginning, catching light stretched by redshift, sometimes bent to us by the gravity of whole galaxy clusters acting as lenses nobody built, and the oldest galaxies came back too grand, too soon. And we watched the honest thing happen. Not panic, not miracles, just a beautiful theory bowing to an ugly fact, and a fresh set of testable guesses stepping forward, each one naming exactly what could kill it. The boundary of what we know shifting in real time. And laid side by side, all 3 told one story. Every time we assumed emptiness, we were wrong. Every time we built a better eye, the universe answered back fuller, older, richer, more connected than we dared to guess. The consistent direction of every discovery is more, never less, which turns the whole question inside out. The emptiness in Phil only 1 was never measured. It was assumed. And it's the one assumption our entire history warns us not to make. Now, let me be as honest with you as I know how to be, because this whole way of thinking is worthless the moment it stops being honest. We do not know that other galaxies hold life. I have not proven it, and I won't pretend I have. It's entirely possible that life is a fluke so staggeringly rare that it happened exactly once, here, and nowhere else in 2 trillion galaxies. That would be strange, given the Copernican principle, but the universe is under no obligation to be unstrange. Maybe the step from dead chemistry to living thing is a mountain almost nothing ever climbs. Maybe intelligence is a trap that destroys itself young, burning up its own world before it can reach the stars. Maybe there's a filter somewhere behind us or ahead of us that keeps the cosmos quiet. We genuinely do not know. And a real answer, one way or the other, may not arrive in my lifetime or in yours. I have to be square with you about that, and I want to hold both possibilities open with equal honesty, because that's the only fair thing to do. It's genuinely possible we are the first. Someone has to be early in a universe that's still young, and maybe that's us, the opening act, the ones who show up before the party fills. That's a real answer, and it's not a sad one. But it's also possible the cosmos is teeming, and we're simply a newborn species with a small net and a brief candle, mistaking our own inexperience for the emptiness of the room. Both of those live inside the boundary of what we honestly know today. And refusing to pretend I can choose between them is not weakness. It's the whole discipline in a single breath. What I can tell you is exactly where the boundary sits, because that we do know. We can now sniff the air of distant worlds, reading a biosignature, a chemical fingerprint of life in the atmosphere of an exoplanet light years away. Here's how, and it's gorgeous. When a planet passes in front of its star, a sliver of that starlight filters through the planet's air on its way to us. Different gases drink up different colors of light, leaving gaps like a barcode stamped into the starlight. Read the barcode, and you read the air. And certain combinations of gases are very hard to make without life quietly breathing them out. That is a real capability we have now. The question is finally becoming answerable, not answered, answerable. And that is the most exciting place a question can be. So here's where I'll leave you, and I mean every word. You are alive at the exact moment the largest question a human being can ask stopped being a matter of faith or philosophy alone and started becoming a matter of measurement. Are we alone? For every generation before yours, that was a question for poets and priests. For yours, it is becoming a question for instruments. The boundary is moving, and you get to watch it move, not read about it in a dusty book. Watch it in the news, in your lifetime, as the eyes get bigger and the barcodes get read. And whatever's out there, whatever fills those other 2 trillion houses or leaves them dark, remember the one thing this whole journey taught us. The universe has never once been smaller than we hoped. Every time we looked, it was more. So when you step outside tonight and see those few thousand stars, the same 3,000 our ancestors saw, don't see a ceiling, see a doorway. Because behind each of those points of light is a depth we are only beginning to measure. And the gap between what we believe and what is true is the most wonderful room you will ever get to stand in. Full of light we haven't caught yet. Full of answers we're only now building eyes to see. That gap is not a problem. That gap is the gift. If you've stayed with me all the way to here, through the parallax and the paradoxes and the ancient galaxies that came back too soon, then this channel is built for you, for the kind of mind that would rather sit with a real question than settle for a comfortable answer. If you'd like to keep standing at that boundary with me, wherever it moves next, I'd be glad if you subscribed. No rush, no pressure, just an open door and more of the sky to look at together. Thank you, truly, for giving me this time. It means more than you know. And keep looking up